In this lesson, we'll complete learning target number 4, doing stoichiometry problems now involving gases. Because we now know the ideal gas law, and there's a branch involving the physical properties of gases on our mole map, we can do stoichiometry problems involving information about gases. Now there's nothing really new in this lesson. It's just that we have a new spot that we can start and stop when we're doing stoic problems. Here's the Unit 5 mole map, and here's the section for the stoic. It looks pretty intimidating. It's built and shows the relationship of 5 different math equations. The first one we learned in Unit 3 was particles equals moles times Avogadro's number. And also from Unit 3, mass equals moles times molar mass. In Unit 4, we learned that the concentration of a solution is the moles divided by the volume. And in Unit 5, if we know the pressure, volume, and temperature of a gas, it's related to moles through the ideal gas law, PV equals nRT. Knowing these equations allows us to take any physical information about a chemical and use a mole ratio to change it into the mass, the pressure, volume, or temperature of a gas, the concentration of a solution, or the number of particles of another chemical during a reaction. Let's do a couple of examples. In example 1, excess magnesium is reacted with 143 mils of 1.5 mole per liter sulfuric acid. We're asked to determine the volume of hydrogen gas produced at STP. Now there's a lot of numbers flying around. This is why I always like to start off with spreading out my balanced chemical equation across the page and making an organization chart. This will be a single displacement reaction, with my first product being magnesium sulfate and my second product being hydrogen gas. It looks like the equation's already balanced. I just need to include my states. Question says I have excess magnesium. This is nice. I know what the limiting reactant is. It's going to be the sulfuric acid. Now that I have everything organized, I'm going to take my complete information about the sulfuric acid and change it into moles. I'm going to use C equals N over V. If I take the concentration of the solution and times it by the volume in liters, that will give me the moles of H2SO4 that got used. Now I can convert over to hydrogen gas by timesing by a 1/1 mole ratio. Because hydrogen is a gas and I have the temperature and pressure, the question states I'm at STP, I'm going to use the ideal gas law to solve this problem. I get 4.8060, but I can only keep 2 sig digs. That's because of the 1.5 mole per liter. Another way to finish this question off is to use the fact that the hydrogen gas is at STP. As soon as you determine the moles, you can use Avogadro's molar volume shortcut and times the moles by 22.4 to get the volume of gas. You'd come up with the same answer. Try out example 2 on your own and see how you do. Pause the video until you get your answer. Here's the answer for example 2. It's describing a combustion reaction with CH4 and oxygen. Start by balancing the equation. A lot of numbers around, so I'm going to organize them underneath their respective chemicals. Here I'm asked what volume of CO2 gets made at 48 degrees Celsius and 102.6 kPa. Now I'm given the amounts of both reactants, and I need to figure out which one is limiting. The first step is to change those both into moles. For the CH4, I'm going to take the mass and divide by the molar mass. For the oxygen, I have to take the molecules and divide by Avogadro's number. Before I can compare these two numbers, I need them in the same chemical. I'm going to convert them into CO2. For the oxygen, I need to times by a 1/2 mole ratio. For the CH4, I have a 1/1 mole ratio. Comparing these two numbers, the one coming from the CH4 is smaller, so it's my limiting reactant. That proves my equation. I wrote it as a complete combustion. Because CO2 is a gas, and I've got its temperature, pressure, and the amount of moles, I have to use ideal gas law to answer the question. (48°C in Kelvin is 321. Now I gotta look at my sig digs. I have 3 sig digs for my temperature and more for everything else. Now I'll trace my moles back. This was my limiting reactant. I had 4 for the mass. So it looks like I'm limited to only 3 sig digs because of my Kelvin temperature. So I have to round this to 17.8 liters for my final answer. I want to show you a gas Stoic shortcut that can be used under certain conditions. It's known as the law of combining volumes. If all the gases in the reaction are at constant temperature and pressure, the volume of the reactants and products follow the mole ratios. you don't need to use the mole map, but it will still work if you don't recognize that you can take this shortcut. Here we have nitrogen gas reacting with hydrogen gas to produce ammonia. Let's write the balanced chemical equation. Given in the question, I've got 1.85 liters of nitrogen gas, and you notice it doesn't mention anything about the temperature and pressure these chemicals are at. I'll assume that they're all at the same temperature and pressure, because they're not stated. That means that the volumes will follow the mole ratios. The question asks me to determine the volume of hydrogen gas. All I need to do is times by the 3:1 mole ratio. This gives me 5.55 liters of hydrogen gas used. To answer question B, I could go back and start with the 1.85 liters of nitrogen. Here it's asked me what the volume of ammonia will be. Again, I'm making the assumption that these are going to be at the same temperature and pressure, so all I have to do is times by a mole ratio. In this case, it's a 2/1, giving me 3.70 liters of NH3 gas. Complete the gas stoichiometry questions listed on your assignment cover sheet.